All right, here we're looking at section 7.3. Our essential question for this section is how can you prove that a quadrilateral is a parallelogram? So let's look at our learning targets. Our first one is to identify and verify parallelograms. And then we're going to show that a quadrilateral is a parallelogram, and here we're again using our coordinate plane, right? So that's very important for these different things. So here's some theorems. So the parallelogram opposite sides converse theorem tells me that if both opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram, right? So in our last section we said that if it is a parallelogram, then the sides are congruent. Well, here we're going to be given side lengths and have to tell if it is a parallelogram. So it's working the other direction. Same thing with this angles converse, right? So if my angles, my opposite angles, are congruent, then this is a parallelogram. So that's what these two theorems are saying, just giving us different resources to show that quadrilaterals are parallelograms. Okay, so here is example number 1. Here we're going to be identifying a parallelogram. So an amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes over the top around in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms, and DC is parallel to the ground. So here we go right here. Explain why the moving platform AB is always parallel to the ground. So here we can look and see that the shape is going to change of my parallelogram is always going to change, but other things that I know are not going to change at all. So here we go. My shape changes as the platform swings around, but the side lengths don't change, right? The length of the swinging arm is always going to be 16 feet, and the length of the platform is always 38 feet, and same here. So since I know that the side lengths are always going to be the same, my opposite side lengths, I know that this is a parallelogram using my parallelogram opposite sides converse theorem. So I also know that this is parallel because DC, right, is parallel to line L, which was the ground. So AB is also going to be parallel to the ground. So this is the transitive property, right? So if I know that AB and DC are always parallel to each other, and I know that DC is parallel to line L, then I know that AB will also be parallel to line L. So now let's look at that drawn out, because sometimes that can help too. So if I know that DC, segment DC is parallel to line L, right, which is the ground, and I know that DC is parallel to AB, right, which I just proved because the opposite sides are congruent. I see here that I have 2 things that are the same. My line segment DC is the same in both of these, so I can go ahead and get rid of that and use what's left. So I have line L and AB left, so I know that line L is going to be parallel to segment AB. Okay, so I used what I know and was able to get what I was unsure of from that. Okay, so here's your first monitoring progress. Try this and see how you do. Okay, so here we're looking at example number 2. So for what values of x and y is quadrilateral PQRS a parallelogram? Well, I know that in order for it to be a parallelogram, my opposite sides must be congruent. So I'm going to go ahead and set those equal. So I'm going to look at PQ and RS. So I know that x plus 9 has to equal 2x minus 1 if this is going to be a true statement. So I want to get all of my x's to the same side. So I subtract an x from both sides. So I'm going to end up with 9 equals x minus 1. Then I want to get x all by itself, so I add 1 to both sides. So I have x equals 10. So there's my x value that will make this a parallelogram, but I also have to have a y value to make sure that this is a parallelogram, because both sets of opposite sides have to be the same. So if I know that x is 10, I have here y equals x plus 7. I found that x is 10, so I can go ahead and substitute that in. So I know that y would be equal to 17. So for the values of x being 10 and y being 17, that is what would make this a parallelogram. So here's some more theorems that we're working with, right? The opposite sides parallel congruent theorem. So if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So if I know that side length AD and BC, first if I know they are parallel, which I do from these arrows, and I know they're congruent, so they are the same length, then I know that the entire shape is a parallelogram. That's what this theorem tells me. I have to have both of those things in order to tell me that this is a parallelogram. So here's theorem 7.10. The diagonals, parallelogram diagonals converse. So if my diagonals, right, of a quadrilateral bisect each other, right, cut each other in half, then I know that it is a parallelogram. So keep these theorems in mind as we're working through the next few examples. So here's example number 3. So the doorway shown is part of a building in England. Over time, the building has leaned sideways. So explain how I know that SV, right, SV is equal to TU. So how do I know that those are the same thing? Well, the first thing I know is I am told that ST is parallel to VU, right? I can see my little arrows, so I know that they are parallel. Here's my arrows right here. I am also told that they are congruent. They are the same length. So since I know those two things by my opposite sides parallel and congruent theorem, I know that this is a parallelogram. And since I know that this is a parallelogram, I know that opposite sides of a parallelogram, right? So here my parallelogram opposite sides theorem, then I know my opposite sides are congruent. So I can say that SV is congruent is equal to TU. So first I have to show and prove that this is a parallelogram, and then I can use that information and my parallelogram opposite sides theorem to show that my sides are in fact the same length. So here's our next example. Here's example number 4. So for what value of x is quadrilateral CDEF a parallelogram? Well, I know that if this is to be a parallelogram, I know that my diagonals have to bisect each other. So I'm already told that this diagonal CE has been bisected because these two shorter pieces are the same length. So now, if it is going to be a parallelogram, I just know that FN has to be congruent to ND. So I can set that up. So 5x minus 8 equals 3x. So I want to get all of my x's to one side. It doesn't matter which one. So I have negative 8 equals negative 2x. Then to get x by itself, I divide by negative 2, divide by negative 2. So I have x equals 4. Because a negative divided by a negative is a positive. So if x is 4, then these two sides, these two lengths are congruent, which means this entire shape is a parallelogram. Okay, so here's a couple more monitoring progress. This is on page 379, so go ahead and try that out. Before we get to that example, I also want to say that on page 379, go ahead and look at the bottom. There's a concept summary there that I want you to pay attention to. So it's different ways to prove that a quadrilateral is a parallelogram. So it's using all of the information that we've talked about, but it's in a really nice chart. So make sure that that on page 379 is in your notes as well. So here's our next example. This is our example number 5. So here I can definitely see that I'm using my coordinate plane, right? So I know that that was one of my learning targets. So I need to show that quadrilateral ABCD is a parallelogram. So how can I do that? So the first thing I want to do is I can do this several different ways. So the first way is to show that one pair of opposite sides is congruent and parallel. So then I can use those theorems to help me there. So I'm going to use my distance formula to help me find the distance from AB and DC. So I want to find the length of those two. So I'm going to use my distance formula. So A was at negative 3, 3, and B is at 2, 5. So I know that my distance formula, right, is also the same thing as making a triangle and using Pythagorean theorem. So I know that my distance here was 2, and I know that my distance here was 1, 2, 3, 4, 5 right here. So I know that 2 squared plus 5 squared equals c squared, right? So 4 plus 25 equals c squared. So c equals the square root of 29. That's what this length right here is. So now I can do the same thing here, is draw my triangle and my side lengths, and I see that I again have 2 squared plus 5 squared equals, we're going to call this x squared, right? So I have different side lengths. So 4 plus 25 equals x squared. So x equals the square root of 29. Well, so now I've shown that they're the same length. So that's a good start. So now I just have to show that they are in fact parallel as well. So I know that I have to find the slope. So let's change color and find the slope. So I know that the slope to get from point A to point B is my rise over run. So I know I go up 2 and over 5. And I know that it's a positive slope because as I go from left to right, it does go up. So now let's look at my slope down here from point D to point C. I see that I go up 2 and I go over 5. Again, it's positive because as I go from left to right, it goes up. So I see that these two slopes are the same thing. So now that I've shown that the length is the same, right? I showed that because it's both the square root of 29. And I've shown that my lines have the same slope, so they are parallel. So I know that these two things, it is a parallelogram. And I can say that for sure because of my theorem 7.9, my opposite sides parallel and congruent theorem. I showed that they were parallel and I showed that they were the same size, so I can say that this is a parallelogram. So the other way that I could do this is I could just, without finding the distance, I could find the slopes of my other lines. And that would also help. I could also find that the lengths, the distances of these, right? That would also help. So there are many ways that I can find and show that this is a parallelogram. For me, this is the most simple, but if you want to just live in slope, you can find just the slopes. If you want to find just the distances, you can find just the distances. Remember, these are our different theorems that we're using. So go ahead and do that. So the last thing is we have a couple of more monitoring progress, and so go ahead and try these and see how you do. Okay, so try these and see how you do. I've also gone and pulled up that concept summary that I was talking about just a few minutes ago. So here's what we're looking at. So I can show that both pairs of opposite sides are parallel. So if I'm using my coordinate plane and I don't want to find the distances, right, if I like to find the slope better, if I find the slopes of all of my sides, that will tell me that they're parallel. I can also find the distances or the lengths of all of my sides because that shows that they're also congruent. So if I don't want to find the slope at all, I can use this theorem. If I am dealing with angles, if I know something about all 4 of my angles and my opposite angles are all congruent, then I know it's a parallelogram. If I know that 2 of my opposite sides are parallel and congruent, that's another way I can prove that it's a parallelogram. Or if I find my diagonals, right, and I can see that they both bisect each other, then I know that that is a parallelogram. So you see that there are 5 really main ways that you can prove that a quadrilateral is a parallelogram. So let's look back at our learning targets, okay? So the first one was to identify and verify parallelograms. Now that we can do using any of these 5 ways as well. So then my second learning target was to show that a quadrilateral is a parallelogram in the coordinate plane. So that was where I'm using slope and using my distance formula to use these different properties to show that these are parallelograms. So now that we've gone ahead and checked off both these learning targets, we've used them both and seen them in many examples, now it's time for you to go ahead and start working on that homework for this section.